number 17 on worksheet 2.5. If you look at this one, all I've done so far is plug in the acceleration due to gravity is 32, and we're using the feet per second because everything else is in feet. So I plugged that in for A. I plugged the 35, the initial velocity, in for V sub O, and I plugged in the initial height of 65. I plugged that in for H sub O. So that's all I've done so far. Now we're going to go ahead and do part A, which says find the maximum height by completing the square and putting it in vertex form. So I'm going to go ahead and complete the square to this equation, put it in vertex form, and then I'll easily see the max height because looking right here, I'm just going to draw the picture of the situation. We got the height of the building, balloon being thrown up in the air, it's hitting some max point up here, and then balloon is coming back down to the earth. Okay, so if we want to find that max height, we're just simply going to find the vertex. So let's go ahead and put this in vertex form. I'm going to bring the 65 to the other side of the equation just to get it out of the way because we're trying to complete the square. And that's one way to do it. The negative 1/2 in the 32 is going to give me negative 16. And I'm going to go ahead and factor out the negative 16 from these t values, from the t squared and from the 35t. The reason I'm doing that is because I can't use the rule of b over 2 squared until I have just t squared. So I'm going to go ahead and take the negative 16 from putting these two together, and I'm going to factor it out. So it'd be t squared minus whatever 35 divided by 16 is, and that gives me 2.1875. And that's what happens when you have real life problems. The numbers get ugly fast, but no big deal, we can handle this. Alright, so we pulled the negative 16 out. I left a space because I'm going to go ahead and complete the square. Now that I have t squared isolated, I can do the b over 2 squared. So I'm going to take the negative 2.1875, I'm going to divide it by 2, and I'm going to square it, which gives me 1.196. So I'm going to add that here, and here's the tricky part. I added 1.196 to this side in the parentheses, but I do not add 1.196 to this side to keep it equal, because what I truly did to this side of the equation was negative 16 times 1.196. That's what truly occurred on that side of the equation. So I have to do the same thing on the other side. So I'm going to go ahead and take negative 16 and multiply it by that 1.196. So that gives me the answer of negative 19.141. That's what I have to do to this side to keep these sides equal. And then from here, it's just a matter of cleaning it up, doing some factoring, making everything pretty again. So I'm going to go ahead and put that negative 19 and the 65 together. The negative 65, sorry. And that gives me a minus, so I got h of t minus 84.141 equals negative 16 outside of, I'm going to go ahead and factor this. It would be two binomials because it's quadratic, t and t, and these numbers look hideous, but remember how we got this number. We took half of this number and squared it. So these two numbers right here are just going to be half of this because they will multiply together to give us the 1.196, and they will add when multiplied with the t's to give us negative 2.187. So looking back at my calculator, I'm just looking back at that. Half of this term was minus 1.094. And both of those would be identical. That's why it's completing the square, because now we can write that as a quantity squared. So I'm going to bring my 84 over, write this as a quantity squared, and I'm done with putting it in vertex form. 16 outside of t minus. Alright, now that we have it in vertex form, we can easily answer the question, find the maximum height of the balloon. It's just right there, 84.149. That would be the y value of this vertex. And if they would have asked us, which they didn't, it reaches that height at 1.094 seconds after Jack released the balloon. So I'm just going to put max height equals 84.141 feet. So there's part A. Part B is a little bit different question than we've seen a lot in class. It says find the time it takes for the balloon to hit the ground. So on this, you got to kind of interpret, oh, hit the ground means the height would be 0. So when I hit the ground, I'm at 0 height. So what I'm going to do, and I could do this to the original equation up here, I could do it to this equation here. I'm just going to put 0 in for the height and solve for the time. I'll use our vertex equation since we took all the time to make it. I'll go ahead and use it. So part B, I'm going to put 0 in for the height and set it equal to negative 16 outside of t minus 1.094 squared and plus 84.141. Just to save time, I'm just going to solve this whole thing on my calculator because really the algebra to it is fairly simple. I'm just going to take the 84, let me clear that off, take the 84 across the equation, I'm going to divide by negative 16, square root it to get rid of the square, and then add 1.094. So I'm just going to do it all on my calculator. Let me move everything up a little bit so you can see the calculator screen. Getting the reflection there off the light, sorry. Alright, so I'm trying to hold it a little sideways here. So I'm going to take the 84 across the screen, so it'd become a negative 84.141. I'm going to divide that by negative 16, and then I'm going to take that answer and square root it to get rid of the square. And then now remember, a square root would really be plus or minus, but in this case we're looking for the higher value. If you look back at the picture, we're definitely looking for the higher value for when it hit the ground. So I'm just going to ignore the negative because I don't want the lower value. So I'm just going to ignore the plus or minus. And then I'm going to add the 1.094 to that, and there's my answer. 3.387 seconds. So, and that is the problem. That's all we had to do.